Hey everybody, this is Larry. This is me going over March 21st Leetcode Daily Challenge. Let me know what you think about this problem. Hit the like button, the subscribe button, join me on Discord. And yeah, reordered power of 2 is today's problem. Okay, starting with a positive integer n. How did you do? I don't know. Did anyone do the contest today? Let me know how you did. I did okay in both. Probably could have been better, but a little bit messy. Anyway, let's get back to this problem. We ordered power of 2, starting with a positive integer n. We ordered the digits and then number. Leading is to return true. We can do this in such that the result power of 2. Okay. Such that the... I mean, this is weird. Isn't it just... I was going to say, isn't it just like the power of 2? But then 46. The leading... We ordered the digit and then... Oh. For some reason, when I think about reordering the digit, I was thinking about reordering the binary digit. So, okay. So, we want to... we basically want to reorder these numbers so that without a leading 0, we want, like, this is true because it's 64, right? So the short answer is that 10 equals to 9, so there's only about 30 or 31 powers of 2, right? So then you could create a frequency table and do a lookup table, and that's basically what I'm going to do. And you can actually be a little bit more clever if you like going up to only the powers of 2 that are greater than the number of digits or something like that, but I'm just going to do it the lazy way, right? So basically, okay. So let's just say we have a set. This is what I call renormalized power of 2. So let's just call it lookup. Let's call it a set, and then we go from for p in range sub 32, just because 2 to the 32 in Python is pretty good. You could do it on your language in whatever. So power of 2 to the p from 0 to 31. So now we're going to get a number x, and of course, to be honest, if I do it in a contest, I probably would do this in a, I don't know, but I've been trying to do things in a slicker way, but every time I do things in a slicker way, I've been doing it dumb. So yeah, so that's just, now we have the power of 2. Let's convert to a string, and then now we want to sort the string, right? So we can do we sort this, and then we convert it back to a string. And then that's pretty much it. We now then add this number to the lookup, and then now for the input n, we do the same thing where, okay, let's actually define this as normalize of a number, and we will return this thing, roughly. Something like that. Ooh. Bless me. Excuse me. Oof. Technical difficulties. Oh yeah. And then we could do a normalize of n as well. And then we just return whether normalize of n is in lookup. I think that should be good. Let's give it a go. Wish there's a quick button for this. But yeah, 10, 16, 23, 46, 55, I don't know, it is a random number. I think 24 is another one that they have, but yeah, let's give it a go. Let's see if this is good. This looks okay. Let's give it a submit. Cool. So what's the complexity of this? Well, this will always take 32, so, and what's the way that I would say it? 32 is the number of bits, so that will always take 32. And of course, you can always actually pre-calculate this. Like we can, if we were to call this function many times, we actually would put this somewhere in memory so that we don't have to calculate it every time. So then it's literally an all of one lookup. We have to use the lookup is not all of one, but the normalized, this is log n, for where n is it's log n, where the log base is 10, because for each digit, for each digit, we have that number, and then we sort it, so it's going to be log n log n, something like that. And then we convert it back to a string, which is fine. And yeah. But again, this is going to be, n. So n is the input, but n is not the input size. The input size is the number of bits. And this is going to be, I would say, n log n, where n is the input size. This is very confusing, actually, saying n, because n is the input n, but n is not the input size, right? Because the input size is 32 bits or whatever it is, and therefore it's 32 log 32 is the complexity of this algorithm. Yeah, and this is assuming that we have this on a lookup table, and that's pretty much it. In terms of space, this is 32, which is log n, log this n, but linear size of the input. But again, you just do it once, right? So yeah, that's all I have, I think. Let me know what you think. Hit the like button, the subscribe button. Have a great rest of the weekend, and I will see you tomorrow. To good mental health. Bye bye.